Guys, the topic that we are going to discuss in this video is generics. This particular topic causes a lot of confusion, but trust me, this is a very handy tool when it comes to A. Avoiding code duplication, B. Preserving the type information. Now, TypeScript generics allow us to create reusable block of code or component which can work with variety of data rather than a single data type. Generics ensures that the program is flexible as well as scalable in long term. So in TypeScript, we can use generics with classes, functions, methods, and interfaces. Now don't worry if that definition is not very helpful. We'll see some very basic examples to understand the need and usage of generics in TypeScript. So we'll start with array. Okay. So we define array like so. Okay, let the variable name colon then number and these square brackets. So this num array 1 variable will hold, okay, the collection of numbers in future. Okay, so in part 4 I also mentioned about this other way of creating arrays. Okay, now if we hover over this, okay, you see interface array, then opening and closing angular brackets, and between these you have this T character. Okay, now in generics we need to write a type parameter between these opening and closing brackets. Okay, and this T is most commonly used and is referred as generic type, and we would use T going forward, but you can use anything in place of T. Okay, just remember that there is no compulsion to use just this character T. Okay, now we'll start with creating the array types. How do we do that? We say type, and let's start with creating the number array. So we say num array, okay, and we are going to say array angular brackets, and we pass in number in here. Okay, now num array becomes number array, as you could see. All right, now let's create one more type, okay, and change this basically number to string. So if I just change it to string in here and also give it a different name, str array. Okay, now str array, okay, becomes string array, as you could see. So any type I write in between these opening and closing brackets decide the data type of the symbols on the left. Okay, so you could also say then boolean like so, and now if you see, this is a boolean array. All right, so now we'll move on to a function and use this kind of logic in there. Guys, the whole theme of this video is that first you are going to see a simple thing, okay, then we'll show you the limitation of that, okay, and then we'll work towards its solution, and eventually we'll see that generics is the best solution. Okay, so we'll modify this function. So now let's see this function. What are we doing in here? So this last item is a function, okay, which takes in an array of numbers, okay, and returns us the last item from this number. Okay, so how can we invoke this? We say const item is equal to last item, and then we pass in the number of arrays. Okay, and this will return us what? 3. Now if I want to now supply, right, this array of strings to this function, okay, we immediately see this error, right? String is not assignable to type number. Okay, so how could I make this function, okay, type agnostic? So what are my solutions in here? Well, our options are A, you decide to create another function which specifically targets strings, right? But creating a new function per data type isn't a great option because we are generating duplicate code, isn't it? Option B, other solution for this problem is basically to set the type of array parameter being passed to this function as any. So if I just say any in here, the problem goes away, isn't it? Now this way you just write your function once and it will work with an array of all types, right guys? And there is a limitation. There is a major problem with this solution. Again, what is that? We lose all the information about the type of value that is being returned. You see, item 1 is of type any, item 2 is also of type any, right? So ideally in this case it has to be number, and in this case it should be string. Okay, but because of this any data type we have lost this information. Okay, so a better solution is to avoid code duplication while still preserving the type information. Okay, and the solution is generics. So let's implement the generic function for this simple function. Okay, so what I'm going to do is I'm just going to take a copy of this, come in here, paste that, and let us comment this thing first. Okay, let's start making the changes. So what do I have to do? Now the solution is, guys, very simple. We replace this any with t. Okay, and we come in here, we use those angular brackets. Okay, and we say t. Now the error from this function is gone, but let's see, does it work? Oh yeah, great. So we see item 1 is of type number, and if you see this, it is of type string. Great, so it works, right? So error isn't there, and we have preserved the type information as well. Okay, now we can also mention the generic types explicitly. Okay, there are two places when we can mention that. The first one is, okay, in here you can mention the generic type, and you could say string, and in here you could say number. Okay, and the other thing that you can do is then you can mention the return type of this. Okay, but TypeScript can automatically infer that, but still you can do that explicitly. Okay, so you say t. All right, TypeScript is smart enough, guys, to infer this automatically. So yeah, but you can still, we have talked about this inference and setting things explicitly at length in this whole series. All right, now guys, we can pass in multiple generic types, meaning we are not constrained to use just one generic type. We can use multiple if we want to, if we have the need to do so. Now let's see an example of the same. Okay, so I'm going to comment this out. We come in here, so we have this function, what this function is doing, right? So this is an getEmployee function which accepts in two parameters, right? ID and code. ID of type number, code is of type string. Okay, the return type of this function is string, and we are returning this concatenated string basically when you're just saying, hey, ID space hyphen space code. Okay, now this thing works great with this. All right. Now what would happen if we do not receive data for ID and code parameters in the data types mentioned in this function? Okay. Well, it will simply not work, right? Let's see that. So we see the error in here, right? Now this function is also a perfect candidate to use generic type. Okay. Now let's change its function then. So we just take a copy of it, comment this out, come in here. All right, let's start making the changes. We say this is of type X, this is of type Y. All right, and we use the generics in here like so, and we say X comma Y. Okay, and now you see this has started working. So what have we done in here? So I have passed number and string. Okay, in here we have passed string comma string, and guys, you can say number or whatever. Okay, string number. It will work in all the cases. Now, the next topic is default types in generics. Okay, now if I what I can do in here is like so. I can just say string comma string, right? We can explicitly mention that, no problem, right? But what if I just want to take this one out? Okay, what you can do is you can set this one, okay, to have a default type of string, okay, and now you don't need to pass this. Okay, great. All right, so next is we have to work on functions with objects. Okay, let's see how we can use generic in this particular category. So what do we have in here? We have this add full name properties. This is a function which takes in this argument obj. Now guys, this is of type any, as you could see, okay, but what I have done is in the ts.config, okay, I have commented out this strict option. Otherwise, if that is turned on, here you will see that error. So to demonstrate this, okay, it's not a right practice. I'm not recommending to do so. Just to demonstrate this, I've turned that off. Okay, so what are you doing in here? So we are saying this function is going to accept an object, okay, and going to return another object. And that newer object, okay, will have all the properties of this object and will also have one more property, that is full name. Okay, and what are we doing? Right, we are expecting that this obj object will have the first name and the last name property, and we are simply concatenating those in here and setting as the value of full name property. Okay, now makes sense this far? But the thing is, guys, it makes perfect sense to apply constraint on this object to have at least first name and last name properties. All right, that ways will ensure that this logic would work, right? So we say colon, and then we pass in here. We say first name, and that property has to exist, and its type should be string, and then last name should also exist, and the type of that should be string. Okay, so now we can invoke it like so. So we say const person1 is equal to this, and then we have passed in that object. Okay, so far so good. But what if I want to pass in an additional property? Okay, let's say I want to also pass in age in this, of age colon 35. Okay, whoa, we get an error. Okay, it says argument of type first name last name age is not assignable to parameter of type first name and last name. Okay, so there's a problem, guys. Now to fix this we require generics again. Let's see how. So I just take a copy of this, okay, comment this out, paste it in here, and I say this object, okay, is replaced with, let's say, t. Okay, now in angular brackets we say t extends this object. Okay, right? So now you can add this, that error goes away. Okay, so let us also log this to the console. Okay, so let me save this. Compiler is already running, and we see the first name, last name, age, and the full name. Okay, so everything works great. So the next topic is generics with interface. Now in previous video, I worked with interfaces at length. Briefly, we can say that an interface defines the structure that a class or an object must adhere to. This interface is used to define what properties, methods, type of those properties, and return types of those methods are to be there. So we have this I-person interface with three members. Okay, name of type string, age of type number, and miscellaneous. For the time being, it's of type string. Now, name and age are fine, but let's say we are not sure about the miscellaneous data type. That's why I said for the time being, let's say it's a string, but we are not sure. So it could be a string or a number or an object, God knows. So we'll make miscellaneous of type generic. Okay, but before we make it generic, so this is your interface. You create an object from an interface. These are all the required members, so you pass in all the values for all of these properties. All right, sounds simple, but how can we convert the interfaces using generics? Okay, so let's see that. So I'm going to just take a copy of this, comment this out, come down. Okay, and I change it to T first, and in here I just mention in the angular brackets T. Now in here, right, you have to make some changes. If you're passing in the string, what do you have to do? You just have to make it a string, okay, like so, and the error goes away. And now in this particular example, what are we doing? We are assigning the string array to miscellaneous. Now what do you have to do? You just have to use those angular brackets again. You have to say string and those angular brackets. Okay, now guys, that's about generics in TypeScript. Okay, thanks for watching. I'll see you in the next video.